For decades, we've been blind, staring into the cosmos with the most powerful instruments ever built, counting galaxies, measuring stars, calculating the weight of everything we could see, and coming up short, catastrophically short. Half the ordinary matter in the universe, billions upon billions of tons of gas and dust that should exist according to our most fundamental equations, was simply gone, vanished, as if someone had erased it from reality itself. Scientists called it the missing baryon problem, and it threatened to unravel everything we thought we understood about the cosmos. But now, after years of searching in the darkness between galaxies, we've finally found where the universe has been hiding its secrets. And the answer was stranger than anyone imagined. Welcome back to the channel. What you're looking at isn't empty space. Between every galaxy, threading through the vast cosmic ocean like an invisible nervous system, there exists a structure so massive, so diffuse, that for generations it existed only in theory. The cosmic web. A lattice of dark matter and gas spanning billions of light years, connecting every galaxy cluster in the universe like pearls on an infinite string. For years, we knew it had to be there. The mathematics demanded it. Simulations predicted it. But seeing it? Actually capturing direct evidence of these ghostly filaments? That was another matter entirely. Until a team of astronomers aimed humanity's sharpest X-ray eyes at a thread of space stretching 23 million light-years across the void. What they found didn't just solve one of cosmology's greatest mysteries. It confirmed that our understanding of the universe, our entire Lambda-CDM model, was right all along. Let's go back to where this story really begins. The 1990s. The era when cosmologists started doing something that should have been simple: an inventory. They wanted to count everything. All the ordinary matter in the universe, the stuff scientists call baryonic matter, protons, neutrons, the building blocks of atoms, the raw materials of stars and planets, and everything you've ever touched. They knew how much there should be. The early universe left us a receipt, written in the cosmic microwave background radiation, that pristine echo of the Big Bang still reverberating through space. The numbers were clear. They added up the stars, brilliant and obvious, burning across the night sky. They counted the gas clouds, glowing in the space between stars. They measured the dust, the debris, everything visible and detectable. And when they tallied the numbers, they came up 40 to 50% short. Half the ordinary matter in the universe was missing. Not dark matter. That's a different enigma entirely. This was regular, everyday atomic matter that should have been everywhere, and it had simply vanished from our accounting. It wasn't in the galaxies. It wasn't in the clusters. It wasn't floating in the voids. Where could you hide half the mass of all the ordinary matter in existence? The answer, it turned out, was hiding in plain sight, if you knew where to look, and more importantly, how to look. Imagine the universe not as scattered islands of galaxies floating in darkness, but as a web. A vast, three-dimensional spider's web woven from dark matter, with galaxies forming where the threads intersect. This is the cosmic web, and it's not a metaphor. It's the actual large-scale structure of everything that exists. Computer simulations of cosmic evolution have shown it for decades. As the universe expanded and cooled after the Big Bang, matter didn't spread out evenly. It followed the gravitational contours carved by dark matter, flowing like water, finding the cracks in stone, pooling at intersections, stretching into filaments across the cosmic voids. But here's the thing about these filaments. They're not made of stars. They're not bright. They're composed primarily of gas, hydrogen. and helium heated to temperatures between 100,000 and 10 million degrees by the gravitational compression of cosmic structure formation. Hot enough to glow in X-rays, but so incredibly diffuse, so thinly spread across such vast distances that detecting them would be like trying to see a single candle flame from the other side of a continent. This gas, scientists theorized, this warm-hot intergalactic medium they called WIM, this could be where the missing baryons were hiding, suspended in the space between galaxy clusters, too hot to be cold gas, too cool to be the scorching plasma in galaxy cores, invisible to most telescopes, almost impossible to image directly. Almost. Enter two spacecraft, XMM-Newton and Suzaku. Not optical telescopes straining to catch photons of visible light, but X-ray observatories designed to see the universe in a completely different spectrum. In the 2000s, astronomers turned these instruments toward a specific target, a filament they believed connected two massive galaxy clusters, Abell 399 and Abell 402. 23 million light-years of suspected structure stretching across the cosmos. If the WIM existed, if their calculations were correct, if they looked long enough and hard enough, they might actually see it glowing in X-rays. The observations took time, patience, years of data collection, painstaking analysis, filtering out contamination from our own galaxy, separating signal from noise. And then, there it was, a faint glow. Emission lines from ionized oxygen and other elements. The unmistakable signature of gas heated to millions of degrees, exactly as predicted, exactly where it should be. They had done it. They had captured the first direct image of a filament in the cosmic web, not a simulation, not an inference, an actual photograph of the structure connecting galaxy clusters. This thread of superheated gas, containing vast reservoirs of baryonic matter, represented a validation of decades of theoretical work. The missing mass wasn't gone. It had been there all along, suspended in the largest structures in the universe, just waiting for us to develop eyes sensitive enough to see it. But this discovery is about more than just finding lost matter. It's a confirmation of our cosmological model itself. The Lambda-CDM model, our best mathematical description of how the universe works, predicted these filaments should exist, predicted they should contain this gas, predicted the temperatures and densities almost exactly as they were found. Every time we make a prediction and the universe confirms it, we gain confidence that we're not just making up stories. We're actually understanding something true about reality. And we're not stopping here. Right now, the Euclid Space Telescope is mapping the cosmic web in unprecedented detail, creating three-dimensional charts of the large-scale structure of billions of light-years of space. Future X-ray missions are being designed, specifically to hunt for more of these filaments, to map the warm, hot intergalactic medium across the entire observable universe. We're entering an era where we can actually see the scaffolding of creation, the framework upon which all galaxies hang. Think about what this means. The atoms that make up your body, the oxygen you're breathing right now, the iron in your blood, all of it was forged in stars, scattered into space, and cycled through structures like these cosmic filaments before eventually condensing into the solar system. These aren't just distant, abstract phenomena. They're part of our story. They're where we came from. For years, we searched for the missing pieces of the cosmic puzzle, and now we know where they were hiding. Not in the blazing hearts of galaxies or the cold depths of intergalactic voids, but in the threads themselves, the filaments of the cosmic web, glowing too faintly for us to see until we learned how to look. Half the ordinary matter in the XMM universe suspended in structures so vast they connect galaxy clusters across millions of light years, so hot they shine in X-rays, so diffuse they're nearly invisible even when we're staring right at them. This discovery reminds us of something profound. The universe doesn't give up its secrets easily. It took generations of theoretical work, decades of technological development, years of patient observation to capture a single image of this filament. But we did it. We solved the mystery of the missing baryons. We validated our models of cosmic evolution, and we opened a new window into the largest structures in existence. The cosmic web isn't a prediction anymore. It's a reality we can observe, measure, and map. So the next time you look up at the night sky and see the darkness between the stars, remember, it's not empty. It's threaded with invisible highways of superheated gas, connecting everything that exists, holding the missing pieces of the universe we've been searching for all along. The cosmos is stranger, more intricate, and more beautiful than we ever imagined, and we've only just begun to see it clearly. If this journey through the hidden structures of the universe fascinated you, make sure to subscribe and hit that notification bell. There are more cosmic mysteries waiting to be explored, and I'll see you in the next one.